Assalamualaikum and hello everyone. My name is Nora Aina Ila Benjamin Zanan. My metric number is B122410478. I'm from section 2 BERT 1/2. Today I will be your throat partner in solving a fascinating past year question from the final examination semester 1 2019/2020. We'll be looking at how control principle apply to something as traditional as making dodol. Please note that this video is produced for educational purpose as part of my project assignment. Let's get started. So, for the first question is 1A. Farah Wahida, a kampung girl, loved to make dodol with her grandmother during her free time. As she's trying the better using a wooden ladle, she wondered whether the wooden ladle is control system. Do you think the wooden ladle is control system? Justify your answer by relating it with the definition of control system. So, for the next is examinate question 1. A character named Farah Wahida is introduced and she is actively engaged in the preparation of dodol together with her grandmother. As she is mixing the batter using a wooden ladle, she asks question, is this wooden ladle a control system? To answer this question, we need to justify our answer based on the formal definition of what constitutes a control system. In the world of engineering, when we talk about control system, we are referring to a collection of components that control or regulate the action of the plant is producing and desired output. Take a look through previous paper of the BEEE 2364 final exam paper and you will be find that this is very common. Try question. It is intended to check whether you are capable of making out the difference between a mechanical instrument and a system. To solve this, we must understand that a control system is a device or set of devices that manage, commands, and regulates the behavior of other devices. A tool like a ladle lacks a controller and an actuator. For a more detailed review of this definition, you can refer to chapter 1 of BEEE 2364 lecture note of or UTM Technology Campus Library resource. So, what is the control system? A control system is normally composed of 3 elements which include the controller, actuator, and plant. Functionally, the control part is responsible of decision making regarding which control action is most suited to achieve the desire of reference signal. As observed, in this case of the electrical dodol mixer, control is implemented by the control part via the speed selection unit and amplifier circuit in the order to control or modify the input signal directed to the motor. The actuator is responsible to translating the control signal into motion. In this particular system, the electrical motor is the actuator and it is translate electrical energy into rotational motion. The plant is the actual system being controlled. Regarding the dodol mixer, the plant includes the stainless steel ladle and the dodol mixer, and the rotational speed to the stainless steel ladle has a direct influence on the dodol mix consistency. Now, moving on the solution for question 1A. Is the wooden ladle is a control system? Definitely the answer is no. Let us understand this point by point. To classify a system as a control system, the system needed to have the ability to control, command, or regulate behavior to produce a desired output. Now, let us take the wooden ladle and identify the components that are needed in the system. when we take a wooden ladle, it will be seen that it does not have the following two components, the controller and the actuator. Without this component, the ladle will be mere passive tool. And in engineering terms, this passive tool will be part of the plant. There is no power source that can make the ladle move on, and brain that will tell the ladle how and when to steer. Another fallacy committed by students is that they are considered the human user as part of the ladle. However, it is asked specifically the wooden ladle without the use to Farah hand, which provide all the force, and her mind, which provide all the direction. There can be no control action by the ladle. For the next question is B. It is Farah's friends who tried her Dodol fell in love with it and suggest to her to take orders. As the workload increases, she decides to replace the wooden ladle with an electrical Dodol mixer. The electrical Dodol mixer consists of few speed options for her to choose from. A simple amplifier circuit is connected to motor, while the motor is connected to a stainless steel ladle. For the question 1, identify the component of the system. For the question 2, draw the block diagram of the system. For the question 3, identify the type of the system and justify your answer. And for the last question, list two disadvantages of the system. Next, the question is because of the popularity of her Dodol, Farah has more work on her hands, such that she decided to improve her conventional ladle by purchasing an electrical Dodol mixer. This new system includes some of choices, a basic amplifier circuit, as well as a motor interface with a stainless steel ladle. Our assignment in this case is to specify the basic components, render the block diagram, and support why this is essentially a certain type of system. In relation to exam pattern, this particular question is high value section, typically carrying around 10 or 12 marks. It tests your capacity to represent a physical description into a function engineering diagram. It's where a number of people typically tend to lose mark if they have not mentioned everything, as well as mention what type of the system it could be. Now, let's see how to bag 2 marks. For the question B1 Roman, now let's list down the major element of this electrical system. First, we have the input, which is the desired speed selection switch. Then, we have the controller, which is the amplifier circuit. We also have the actuator, which supplies the mechanical power, and it is the electrical motor. Additionally, we have the process of the plant, which is the stainless steel ladle or mixer. Lastly, we have the output, which is the actuator rotation of the Dodol mixer. As we leave this out, we can see that it's an open loop system because this speed is determined by means of the switch. There is no sensor to ensure whether or not the Dodol is in the spinning at the speed. So the next question is solution for question B2 Roman. Let's draw the block diagram of Farah electrical Dodol mixer. First, we start on the left with our output. We draw an arrow label desired speed selection switch going into our first block. This first block represents our controller. Inside, we write amplifier circuit. From the controller, we draw a signal arrow leading into the next block, the actuator. This is our electrical motor. The output of the motor then goes into our final block, which is the plant of the process. Here, we write stainless steel ladle or mixer. Finally, we draw the last arrow pointing our out of represent our output. which is the actual rotation of the Dodol mixer. The common mistake here is forgetting to label the error of getting the order of the blocks mixed up. Remember, this is an open loop system. So, notice that there is no feedback line returning from the output back to the input. Once the switch is set, the system runs forward without checking if the speed is correct. Drawing it clearly like this ensure you get the full marks for the diagram. Now, for the question B, part 3 Roman, we need to identify and justify the type of system Farah is using. Based on the component and the block diagram we just drew, we can conclude that this is an open loop system. The justification is simple. The system has no feedback mechanism to monitor or adjust the motor speed automatically. This means the output, which is the speed of the ladle, depends entirely on the initial input speed setting provided by Farah. In an exam, remember that the defining characteristic of an open loop system is the absence of a feedback loop. Even if the Dodol mixer gets thicker or the motor encounters resistance, the system will not know to increase power because it is listening to the output. The question B for Roman, first, the most significant drawback is that the system is highly sensitive to disturbances. In our case, as the Dodol better thickness, the load on the motor increases. Since there is no feedback to tell the motor to work harder, the stringing speed will be naturally dropped, leading to the consistent mixing. Secondly, the system has poor accuracy because it cannot self-correct. It simplifies for lower to input switching setting regardless less of the actual outcome. Note for my fellow students, be careful with our slides. The current slide incorrect lists an advantage on a closed loop system. For an open loop system, remember that it cannot maintain a consistent speed when better thickness or load change. Last question is question C. Here is the question is, the electrical Dodol mixer requires speed to produce a rich consistency. Therefore, Farah decided to install a sensor detect speed to the stainless steel ladle rotation. Now, let's solve this final part step by step. For question 1, the sensor will be a tachometer for rotational speed. As for question 2, we will create the new block diagram. We begin with the input, switch lead to the summing point. Instead, the signal passes through the amplifier, followed by the motor and eventually the ladle. Nevertheless, this time, we will include the feedback path coming from the output. We decide this line returning to the output, labeled as tachometer and connected to the summing measure point with a negative sign. As the question 3, this becoming a closed loop system. Our reasoning is based on the utilization of a feedback sensor to observe and examine the resulting output speed. The latter compare it to the expected input, diminishing possible error accordingly. Lastly, for the final question is question 4. One of its greatest strengths is that it offers precise and reliable mixing speed, irrespective of the battery thickness and output change. Even the Dodol become thick and heavy, this feedback will be able to note the reduced speed and instruct the amplifier to boost its intensity. So, for the solution question C1 Roman, the best sensor for this job is a tachometer, which measure angular speed. So, why a tachometer? Well, Farah needs a consistent speed to get that perfect Dodol consistency. A tachometer is the best fit because it directly measures angular speed and convert it into an electrical signal. This signal is what tells our brain, the amplifier, exactly how fast the ladle is turning. So it can just adjust the motor power if the batter gets too thick. The solution question C2 Roman. We must draw the diagram. We begin on the left with our input, the desired speed selection switch. The signal now entire a summing point, which is a circle with a plus minus sign 30. It is here that the magic occurs. It checks out what we want, what we is. The signal moves forward to our controller, the amplifier circuit, and on to the actuator, which is the electrical motor. The motor drives the plant, our stainless steel ladle, to produce the output or the actuator rotation speed. Now, to maintain this speed during the Dodol thickening, we add the sensor, a tachometer. We draw a feedback line from the output through a block labeled tachometer and connect back to the negative sign of the summing point. Why use a tachometer? Because it is specifically designed to measure angular speed. It converts the rotational of the ladle into an electrical signal that the amplifier can understand. This allows the system to detect if the Dodol is slowing down the motor and immediately adjust the power to maintain that perfect consistency. This complete diagram clearly shows a closed loop system. For solution C, Roman 3, let's identify the type of system Farah has designed. Based on our design, we can clearly see that this is how a closed loop system. This justification is that the system now incorporates a feedback mechanism. By adding the tachometer, the output, which is the actuator, the actual rotation speed of the ladle, is continuously monitored and feedback to the controller. This allows the amplifier to compare the actuator speed against the desired input and automatically adjust the motor power to correct any error. In an exam, always remember, if the system can sense this on output and make changes to fix a mistake, it is a closed loop system. This solid justification is key to securing your full 3 marks of this part. Finally, let's look at solution question C, Roman 4. The major advantage of this new setup. The most important benefit is that its closed loop system provides an accurate and consistent mixing speed regardless of batter thickness or load changes. This is because the tachometer is consistently watching the ladle. It can detect if the thick Dodol is causing the motor to struggle. It immediately sends this feedback to the amplifier to boost the power. Unlike the open loop system, which would just slow down and result is uneven mixing, this system ensures that Farah gets the exact rich consistency she needs for a high quality product every single time. This effectively solves the problem we identify early and is worth a solid 2 marks in your exam. Before we conclude, let's test our understanding with a quick challenge. Which component is essential to transform an open loop system into closed loop system? It is A. Motor, B. Amplifier, C. Sensor. If your answer is C, sensor, you are exactly right. In our case study, adding the tachometer allows Farah system to monitor the actual speed and correct error automatically. To recap, we identify the component of the electrical mixer, modulate its open loop behavior, and finally upgraded to with a feedback loop to maintain consistently speed despite disturbances. If you will be able to follow this step and answer for the question, you now have a strong understanding of this core topic in control principle. As a reminder, this video is intended for academic purpose and follow the official UTEM syllabus. Thank you for joining me today. I hope this breakdown helped you in our study. Good luck with your exam and thank you. Bye-bye.